Hey there, camels. I want to continue our little series on locals today. So locals are a feature that's part of the branch of the OCaml compiler that we're developing here at Jane Street. And it's publicly available. There's a link down in the description. And there's been a bunch of videos that I've been making about these. And this is going to continue that series, introducing yet another concept called regions and the regional mode. So let's dive right in. First, I want to write a little function that maybe its behavior is a little surprising. So if I just take a simple thing like this. So here I'm taking x as a local string to f, and I'm just going to return it. Does that work? Well, let's see. I'll compile this, local.ml. Oh, and there's a syntax error. What have I done wrong? Oh, no, of course I can't say local underscore string. I have to put the local here. Of course, I don't know why I made that mistake. And then this works, and it infers a type that this f function is local string to local string. So already something very strange is going on, and this kind of violates the little model that I've been building up for you in these videos. So here I say a local value does not escape its region. And yet every function defines a region. And so here, if x is local and I'm returning x, that looks like it's escaping its function region. Well, it turns out that something slightly sneaky is going on here, but I want to bring in one more example before I really reveal what's going on. And that's to write the function iter. So we'll have a function iter here, and then we'll have some function that we then iterate down a list. So I'll have a list, match list with empty list. We're all done. Otherwise, we have x and then x's. And let's see, what do I want to do? I want to do f on x and then iter f x's. Okay. And then if I try to compile that, of course, syntax error. I forgot to put in the little bars. Okay, and that works. Oh yes, okay. So I thought I had forgotten the rec. No, this is good. This is good. But we see here that this iter function is inferred to have type AROB to a list to unit. That's surprising. I was expecting it to be a to unit. I guess there's no check here that this is unit, which is a little surprising. But what I really want this to do is I want this to be local. So let's just say that that's local, right? Because I'm not doing anything with this function. I'm not passing it somewhere else. I'm not trying to store it in a ref. And this means if I put local here, that any caller to my iter function doesn't have to allocate a closure on the heap, right? That closure, if any closure is needed, can just get allocated on the stack, which is really nice. So let's give that a try. And so that works. I can say that this is local. But again, something strange is going on here. So I've said in previous videos that a tail call is outside of the region of a function. Well, this here is a tail call. And if this is outside of the region of the function, then why is it that I'm allowing f here? Okay, so both of these have this strange behavior where some things that say they can't escape regions actually are escaping regions, and maybe it looks like there's a bug somewhere. But it turns out everything is okay, and that's because whenever we've been saying local underscore here, it's been a tiny bit of a lie. Well, when I've been saying local underscore specifically in a parameter position, it's a tiny bit of a lie. Oops, I didn't mean to delete that. How do I undo? Maybe I do that. Yes, okay. This is the hazard of using multiple editors. So here, what I really mean is regional, which I'm not even going to write with the underscore because it's not a keyword. We can't write regional even if we want to. And what's really going on is that if I have a local parameter, then that's actually regional, and a regional thing can escape exactly one region. So local parameters are actually regional. Regional variables can escape exactly one region. Well, maybe one or zero. It doesn't have to escape. So the idea here is that if a parameter comes in, if I label a parameter as local, well, someone had to pass it into the function. And so if it's coming into the function, then that means that it can live at least one region beyond my function. And so it is safe to let it escape as long as it only escapes that one region. So here for f is inferred to have this type local string to local string. Well, that means that the string that comes in must be local, but then the string that comes out also must still be local. It was regional inside of f, but now that it's escaped that one region, it has to go back to local. And so we need to infer a local return value here. Otherwise, it would be unsound, and I could use a function like f essentially to smuggle a local thing into a global thing, which would be terrible. Then we'd have a local thing which can escape. That's bad. Something quite similar is going on here with iter. So in iter, this f, again, I've annotated it local, but because it comes in as a parameter, f really is regional. And so this regional f, I can pass it to my recursive call to iter, my tail recursive call to iter, and it's okay. So it escapes the little region of iter, which sort of ends at this semicolon here, and gets passed to the next iteration of iter. But again, that's okay because f is not really local, it's regional. And again, there's no way of writing regional. This is just the treatment that happens to function parameters that are labeled local. So just to prove to you that something actually is going on here, let's say, oh, I've labeled too many things f. I'll call this one id, because it's very much like an identity function. So if I just change this now, let me just reaffirm that everything is still working. It's all good. If I change this here to id, this is just this function up here applied to f, and now try to compile, then, oh, what has happened here? Oh, because I said string. Let me get rid of the string bit. I don't really need that. I just need it not to be int. And so here, this local value escapes its region. What's happened here is that this id function, did it get printed in my output? No, it didn't get printed in my output. So let's just comment this out. I just want to show you all what the type here is. So id, this new id function is local alpha to local alpha. And then if I uncomment and then build, so what's happening here is that this f was regional, but I passed it into id, which it then got returned from, but now I've sort of forgotten that it's regional. There's no way of marking the return value of a function as regional. So smuggling this f through id, sort of we forget that it's regional, and it's now actually local, and then I can't use a local thing in a tail call because I'm outside of the region. So something really is actually going on here. I think, weirdly, if I do something horrible like this, does that also make an error? No. Oh, it just infers that not to be local at all. Oh, and that's because this never returns. That's just, okay, that was just a terrible idea. Let's forget I did that. Okay, so we're back here to this. So that's regional, which is just sort of helpful in case you're sort of playing around with this and realize, gee, something strange is going on, that's regional. The other thing that I wanted to discuss in this video is exactly where regions come into being. This is being a video all about regions. So here we've said that a region surrounds every function body, and that's true. Regions also surround loops. So I'm going to change my iter here, and let's get rid of this regional thing, and we can even get rid of id. We're not going to need that one anymore. And now, instead of a list, I'm going to iter down an array. And so, of course, the way I'm going to do that is not with a recursive function, but with a loop. So I can say for I equals 0 to array.length of array do. And then what do I want to do? I want to call f on array I. Done. Okay, let's see. Does that work? Oh, of course, I don't have this match array with anymore. That makes no sense at all. Okay, now this is pretty good. So I said earlier that that a region is created around loop bodies. And that's really nice because what it means is that if this f itself does any allocating, then that it does any local allocating in particular, all of that can be deallocated before I loop around my function. So let me draw that out a little bit. So this f here, we're going to say is local, what would it be? A to local unit, I think would be the right type for it. Yes. Okay. So again, let me try to sort of explain what's going on here. I want this to be, this f here, I want it to be able to take in its argument locally. Oh, wait, that doesn't matter very much for the example. Let's forget that because that just confuses things and doesn't help anything. what's important here is that this f is returning something locally. Now, the unit itself is not very interesting to say local about, but when we have a local returning function, then what that means is that function allocates in its parent's region. So this f, if it does any work, maybe it has to allocate a bunch of work to do whatever it's doing. All of the work, all of the locals that f allocates will end up getting allocated in the region created by this for loop. And so that region, because we're in a loop here, every time the loop goes around, that region ends, and we can then deallocate all of that stuff. Otherwise, it would mean that we're actually taking O of n space every time around the loop, building region upon region upon region upon region. That would be really bad. So this little fact about regions isn't maybe as useful as some of the others because the loops in OCaml, there's sort of no way to return from a loop other than like storing something in a ref, say. But of course, refs only work with globals anyway. This one, again, doesn't matter so much for typing, but it does if you're thinking about the memory allocation behavior of your program, right? So for that, it's really helpful to know that all the local allocation that happens in a loop ends when the loop goes around. Anyway, that's really all there is to say about regions. So I hope this has been interesting. Thanks very much for watching. Bye.